This will start the lecture notes for Chapter 13, Surface Water, Section 2. Section 2 deals with stream erosion and deposition. The key ideas of Section 2 are that as streams flow, they erode rocks and soil. They transport these sediments over long distances and deposit them in areas of quieter water. The learning objectives for Section 2, we're going to describe how streams weather and erode Earth's surface. I'm going to describe how streams transport and deposit sediments. And finally explain how deltas and alluvial fans form. How streams weather and erode material. Running water in streams and rivers wears down Earth's surface by breaking up bedrock and by removing eroded rock over and soil materials. Running water breaks up the bedrock over which it flows primarily by mechanical means. Rapidly flowing water has a lifting effect that can split off and remove rock fragments. Most erosion occurs when running water abrades and hammers away at its bed by using sand, pebbles, and boulders as cutting tools. Abrasion also wears down the cutting tools themselves, producing the rounded boulders, pebbles, and sand grains that are commonly found in the beds and streams of rivers. This is a graphic illustration of river rounded boulders. Potholes. Cutting tools, moving pebbles and boulders, are involved in the formation of potholes in the bedrock of rivers. Potholes are oval or circular basins which form when water in a river develops small whirlpools. As sand and pebbles or even small boulders swirl around in the whirlpools, they grind potholes in the bedrock. This is a picture illustrates some potholes. A good example of potholes, if you ever get the chance to go to Goodman Park in northern Wisconsin, outside of Blackwell and Goodman, the Peshtigo River there has carved potholes into the rocks at that particular part of the river. Along James River in Virginia, potholes formed in granite. The river no longer flows through there except for extreme cases of rain, but it has carved these potholes in the past. Along Mohawk River in New York, potholes formed in limestone. And these areas here are what we're talking about, the potholes. What is a plunge pool? Plunge pool is a basin that has been worn away at the base of a waterfall by the action of falling water. Abrasion by churning particles also plays a role in forming a plunge pool. Many waterfalls have plunge pools. And as we've been watching the series Gold Rush, Parker has been looking at the base of waterfalls mainly for the plunge pools. The Porcupine Creek adventure that the original crew looked at, they were looking for these honey holes or the plunge pools at the bottoms of the waterfall where the gold would be deposited. How a plunge pool forms. Suppose we have a canoe on the brink of a waterfall, and what you would see from your boat, if you went over the waterfall, you would fall into the plunge pool, and typically there's a recirculating current, and in the case of Porcupine Creek and where Parker's looking now, the gold would be deposited down here at the bottom of the plunge pool. This is how a plunge pool looks. It actually has water in it. When I lived on Okinawa, we used to go up to the north end of the mountain, and there was a really neat plunge pool at the base of a freshwater waterfall up on the north end of the island. Chemical weathering. The rivers also exert a chemical stress on the bedrock. The water is a powerful solvent, and many minerals and rocks are easily dissolved. Such minerals are the ones which contain calcium. Calcite and dolomite are the most common. Rocks containing these minerals, like limestone and marble, are easily weathered away by the streams and rivers. How do streams transport material? All the materials transported downstream by a river is called load. A river carries its load in three ways. Number one, in solution. Number two, in suspension. And number three, in its bed load. If the river flows over rocks that dissolve in water, then the river's load is transported in solution. Common minerals transported in solution are calcium, magnesium, and bicarbonate. Most from river solution load comes from groundwater seeping into the river. Materials in suspension. When the river looks muddy, it carries materials in suspension. Suspended material consists of fine particles of clay, silt, and fine sand. Although these materials are heavier than water, the turbulence of the stream flow stirs them up and keeps them from sinking. This river, you notice the brown color. This is because it's carrying the material, the silt and clay, in suspension. Typically this will occur after a big rain event or in the spring when a river floods. Some rivers, though, are this color because of the material they're transporting from farther upstream. Transported materials on the bed load. A river may also transport materials in its bed load. The bed load materials are too heavy to be carried in suspension and are slowly dragged or tumbled on the bed of the river, especially at high velocity. The relative amount of river's load depends on the nature of the river, the climate, the type of bedrock, and the season. As a general rule, most of the river's load is transported in suspension. The load increases with human land use. That means more material enters a river when humans interact with the river. Some of the bed load materials, you notice the rocks and this piece of junk that's being transported down the river on the bed of the river. Competence and capacity. The ability of a stream or river to transport material is described by its competence and capacity. Competence is a measure that describes the maximum size of the materials carried by the river. Capacity is a measure of the total amount of sediment a river or stream can carry. The competence and capacity increase during floods. Therefore, much of the erosion created by rivers occurs during floods. Stream deposition. All rivers and streams will eventually deposit the material they carry. While some of the materials may be deposited along the channel, most of the load is deposited where the river empties into a sea or lake. A delta is a common deposit that forms when a river flows into a quiet or large body of water, such as a lake, an ocean, or an inland sea. How deltas form. River water comes to a standstill at a delta where most of the river's sediment is dropped. As long as the amount of sediment is larger than the amount that can be taken away by the currents, the deposit grows. A river flowing into its delta, it splits into branches called distributaries. A delta is a delicate balance between deposition and erosion. This is the Mississippi Delta, and many of you may be familiar with it if you watch the television series X-Men or if you watch Swamp People, because the alligator hunters in Shelby are working in this area of the Mississippi Delta, back in the backwaters. Alluvial fan. A fan-shaped deposit is called an alluvial fan. Alluvial fans form at the base of a mountain where the slope changes drastically. An alluvial fan differs from a delta in several ways. Number one, the deposit is formed on land, not in water. Second, the sediments are coarse sand and gravels rather than silt and clay. And third, its surface is sloping. It isn't flat like that of a delta. This is a picture of an alluvial fans. This area, especially right here, is what we're calling an alluvial fan. And again, on the side of a mountain, and it's sloped, and this material is sand and gravel rather than silt that's transported by this river. This concludes the lecture notes for Chapter 13, Section 2. And again, after you listen to the lecture notes, complete the online review for Section 2 that can be found in your My Big Campus account.